space-time metric engineering is a mouthful, but it accounts for the physics of the amazing performance seen with UFOs. In this video, Dr. Hal Puthoff explains how, based upon textbook physics, not fringe physics, but there's a catch. Watch this video and find out what holds us back.
Let me pick another one, space-time metric engineering. Here's the mouthful. This happens to be the area that I personally was the leader on. The question is, can you account for what we're seeing based on known physics? And of course, all the pilots get back and say, oh my God, I can't believe these things. I mean, they're violating the laws of physics. They're standing still, they're taking off instantly. Like they don't have any inertial mass. There's this, we don't know how that could even be possible in principle. Well, that's fine for the pundits and the media and even the pilots to say. But the truth of the matter is, we can't account for them. We can't account for them. By taking an engineering approach to general relativity, Einstein's theory of general relativity. So what does that mean? Well, all of our electronic devices, this device I'm holding, your cell phones, the lights, whatever you want to say, are all using electromagnetism. And electromagnetism has its foundational equations, and everything that we have is really built on what the equations predict. And that's a completely mined area of science and technology. But when it comes to general relativity, Einstein's theory of general relativity, that's mostly been in the purview of astrophysicists who are trying to figure out what happens when black holes merge or whatever. No one ever thought of taking the equations of general relativity, just like we have the equations for electromagnetism, Maxwell's equation, and say, well, suppose we could engineer those equations. Suppose we could build something based on those equations. This is textbook physics we're talking about, not fringe physics. So one of my jobs was then to make a list of all the weird anomalies reported about these objects. Actually, from my standpoint, the weirder the better, because if somebody is making up something and it's fraudulent and a hoax, they're going to try to say something that's, kind of could sell, makes sense. But when somebody comes up and says, well, I was outside the craft and it was only that big, but when I got inside, it was a football field in size. So we list all the weird aspects that have been reported and list all what would be the weird things you would find if you could engineer general relativity equations, and they matched up hand in glove. I'll give you some examples. For example, warp drive. How about zipping across the universe? And you always hear, you can't do that. It's, you can't beat the speed of light and so on. Well, that whole thing about not beating the speed of light has to do with Einstein's special theory of relativity. But it turns out that in general theory of relativity, there's a way to do that. Here's a very famous astrophysicist by the name of Alcubierre. He was a Star Trek fan. And so he said, I wonder if I could find solutions in general relativity that would let me make warp drive. And I have a lot of constraints on that. I want to leave at breakfast time, have breakfast time at home, go to Alpha Centauri for lunch, come back and have dinner with my family, and I want them still to be the same age I am. And on the trip, I don't want to be turned into salsa in the back of the spaceship with giant accelerations. In fact, I'd like to just feel like normal kind of things. And so we worked through that solution and developed what's now called the Alcubierre warp drive. He published this in an absolutely tier 1 physics journal that deals with general relativity. And so it's a very sort of famous picture of what his warp drive solution looked like, where you sort of depress space-time metric, as we call it, in front of the ship and build it up behind it and let space-time metric push you through and so on. So there's a whole cottage industry of general relativity theorists who are working on various forms of warp drive and so on. Well, what about the velocity of light constraint? Again, in general relativity, you can solve the equation and come up with something called, for example, a wormhole. And again, I'm not talking about fringe physics. This is textbook material. Matt Visser is one of the great general relativity theorists. And if there are any engineers in the crowd, for the engineers in the crowd, I would point out that, well, what do you mean by velocity of light? Velocity of light is given by a little equation here, 1 over the square root of the magnetic permeability and the dielectric permittivity of the vacuum. So if you want to go faster than the speed of light, you just simply arrange to reduce the value of those constants. And now the effective speed of light in your engineered region is much higher. And so even though you're zipping through a faster than speed of light as far as anyone on the ground is concerned, actually within your engineered space, you're not actually beating the speed of light, but it works in principle. So the take-home message here is reduced time interstellar travel either by ET or ourselves in the future is not, as naive consideration might hold, fundamentally constrained by physical principles. And it can be addressed, the exotic physics, in engineering terms, metric engineering. So you might well ask, okay, well then why aren't we zipping around the universe? And, well, unfortunately, when you solve the equation, you say, oh yeah, all these things could be done. What would be the engineering required to do it? Well, in our solution so far, it's, oh my gosh, we have to have so much energy density compactified in such a small volume. There's no way we can get there with our present engineering smarts. So it's going to be far future for us unless we happen to find some kind of back door that lets us through. So in fact, that was one of the papers. In fact, this is the paper that I published. So it's one of the Defense Intelligence Reference documents, one of the 38 that went up on the special website. But by the way, as I mentioned, we didn't tell these authors that we got 30. Well, what about going into matter? Well, I mean, it just turns out that one of the outcomes in the list of weird things from space-time metric engineering is that materials under those conditions are so hardened that they're like made out of diamond or better, and the rest of the world looks like butter. So even going into matter, going high velocity into the water or whatever, is one of the predictions of the modeling. So haven't talked about it specifically. I mean, there have been some reported cases, but you know, they came from the public, so you don't know whether to believe it or not, of craft going into mountains and stuff like that. No explosion, no. So anyway, that's all just debris, intellectual debris on the table that we're trying to put together like a jigsaw puzzle. And so there hasn't been any particular reason not to talk about it or to talk about it. I mean, the data we have, and we're following the data, that's where we want to concentrate. We don't have good data on that, so I'm happen to be personally interested because it's one of the predictions of the modeling. But so anyway, that's where that stands. So anyway, is there anything you can learn from this that can help us in terms of evaluating observations in the world associated with unidentified aerial phenomena? I'll just give you one example. And I have about 1,000 I could give, but that would take a week or so. In this room, most of the electromagnetic energy you can't see. Why? Because it's in the infrared in the form of heat. And then there's a very narrow band in the electromagnetic spectrum that you can see, and that's what we call, you know, the visible spectrum. And then there are higher frequencies into the ultraviolet and beyond that we don't see. Now it turns out that one of the side effects of engineering the space-time metric to get this kind of flight performance is that we call it blue shifts the frequencies. All the frequencies that are involved get moved to a higher frequency. That's just built into what the equations say when you generate these anomalous effects. So what that means then, and it has significance for us, is the infrared we don't ordinarily see gets blue shifted up into the visible. So when we hear that these craft are so bright and so luminous when you see them, it's not a surprise. And then what was in the visible spectrum gets shifted up into, let's say, the ultraviolet. And so if you get too close to one of these things that are powered up, you'll get a sunburn, often reported by people who've claimed to have gotten close to a craft. And if you get too close, you might actually pick up some of the blue shifted radiation from the visible that's now blue shifted up into the soft X-ray region and get radiation poisoning. And there have been cases where that's been reported. So having this set of equations and seeing what they predict and then going out and matching against real data, I mean, that's really a boon. I'll give you one example. Claris Island in Brazil, 1977, 1978, they had a massive wave that lasted for many days of like a scene from Close Encounters of the Third Kind or whatever. Hundreds of advanced aerospace vehicles were observed by civilians and the Brazilian Air Force investigative team. They set up a whole operation called Operation Plate by the Brazilian Air Force. More than 1,000 pages of documents, logs, sketches, and maps. More than 500 photographs. 15 hours of motion film. Physiological effects and medical injuries. And so in our ATIP program, all this information was compiled into a big database, and we did our best to analyze the implications. So part of what led to the engineering, space-time metric engineering as we call it, is when you see all these injuries, you say, well, what could have caused that? Well, this blue shifting would cause it. Well, where do you get blue shifting? Oh, from Einstein's equations, if you were able to generate this space-time metric engineering.
Thanks for watching this video. Click here to watch our playlist of short, credible videos covering all aspects of the UFO phenomena. And make sure you subscribe to catch the new content posted every week.